Hey, can you hear me?
Yes, can you hear me?
Yeah. Hey, sorry I'm a couple minutes late. I was having some audio issues connecting. How's your day going?
Pretty good. Just just practicing interviewing, but how about you?
Pretty good as well. Yeah. Looking forward to practicing some interviewing with you. Um,
Awesome.
so today it looks like you're up for system design, right? And this is specifically a mentorship session. Is this your first system design or mentorship session? Have you used interviewing.io before?
Yes, I did a mock system design a couple of months ago, but I needed some practice, so I've been reading System Design Interview Volume 2. Um, I implemented a stock exchange. One of the things I've had a lot of practice since then.
Okay, sweet. Um, so I think the mentorship sessions. I don't know if you intended to specifically do this one, but they're a little bit more kind of open-ended. I like to ask kind of what you want to get out of the interview. We can kind of tailor it however you want. I
Mhm.
can give you. It looks like you're a pretty experienced person. Like 10 plus years of experience is what's written down. Is that accurate?
Yes.
Okay. So I'm assuming you're kind of going for staff plus roles, like staff or principal engineer roles or senior engineer roles?
Right now, senior engineer, yes, and
Okay.
eventually soon staff.
Cool. Sounds good. Yeah, so I mean, we can work through kind of like just the system design question together. Do you have anything, I guess, in particular that you would like to get out of today's session before we jump in?
Yes, my goal is to work with you through a system design question. So I would like it to be like a normal interview almost. So we just say, okay, do this. You start with do X, Y, and Z, and then
Mm-hmm.
I start, and then we keep go for a bit, and then just iterate together instead of just full presentation mode. It's like an interview where we're also collaborating
Right.
together more.
Yeah, I don't do any of those kind of interviews anyways, so I think that'll be we'll always do that. Have you ever had someone kind of walk you through a generic strategy for system design interviews? Because like one of the things that people struggle the most with, I find, is time and knowing what stuff to talk about and how to kind of make use of that bidirectional communication. Do you have kind of like a strategy when you're going into these things? If not, I think we should spend just a couple minutes to talk briefly about that.
Yes, I've been watching a lot of these videos, but I'm still working on that, and I've been just doing some practice sessions with myself. But what's I would really like to go over that. That was really helpful.
Okay. I'll send you a link to a blog post in the main chat here, just
Okay.
so that you can take a look at it later on. You don't have to read this right now; it's pretty lengthy, but I think
Okay.
there's kind of four main steps, and uh, we can put them here on our whiteboard in Excel draw so that we kind of do them together over time. But the first step is just doing a basic outline, right? So coming up with the requirements, asking lots of questions. The second step is getting the high level design and making sure that you get sign off on it. And then you go into
Hmm.
more detail. And then lastly, you make it scale and make it operational, things like that. You do follow up questions, right? Um,
Yeah.
the super important thing, I think, where people get really lost is how much time to spend in each one. So we've got about
Right.
an hour today. Um,
Hmm.
and let's spend maybe like 45 minutes or something on this together, and then we'll spend more time on other things. But like you're probably looking at like 15, 10, maybe like 10 and 10, something like this. Maybe actually closer to this, right? So
Yeah.
this is roughly how you'll want to spend 45 minutes here, right? And then obviously
Okay.
there's more kind of specific things. Um, that blog post will walk you through like back of the envelope math and tips and tricks and stuff like that. But I think
Okay.
let's just maybe start here, and you can use this as a kind of a cheat sheet as we go through the interview, and then you can look back at this video and kind of time yourself and how things went. Does that
Yes.
sound good? I know that's a super, super high level overview. We can spend more time at the end in more detail.
Okay. Yeah. Yeah. That sounds good to me.
Cool. Any questions, I guess, before we jump in?
Well, I think the questions I would have are mostly things we could answer by jumping in, like the nature of what we would discuss in each section. So I think let's jump in.
Okay. Yeah. So I want us to design a job scheduler for our cloud service. And it'll be used by any customer in the world. So it'll be a public facing service.
Mm-hmm.
And what I really want to have customers be able to do is they can specify a job, and a job is kind of any kind of code or algorithm that they want to upload. And I want them to be able to run that job either as a one-off, so kind of like a manual trigger, or on a schedule. So like every Tuesday at 2 p.m. or something like that.
Okay. Okay. So it's kind of I'm gonna write that out on the text file. Job scheduler, public facing. So I'm gonna make these kind of like the functional requirements, because I want to. My understanding of the first section is outline use cases and constraints of the system. And I know that the first part is often just like, what are we building? Like the overview. Job scheduler, public facing. Customers post a job. That can be some kind of code. I'll have a question about that in a second. And can make it one-off jobs or scheduled. Maybe even repeat. Does that include everything that you mentioned? Okay. And then a question about posting a job. Does that mean they upload code?
Right. Yeah, I'd like us to discuss that a little bit. Like ultimately what I was envisioning is I want customers to be able to put in kind of any code of any language that they want. But I'm open-minded as to how, we should create a surface that allows them to do that in the best possible way. But, for example, like maybe I'm writing in Python and my program is like print hello world. And then I go into C# and I write a program that uploads a file into Amazon S3, AWS S3, and then downloads that and then puts it into Azure Blob or something like that. So I want a lot of flexibility in terms of the computation that a customer can upload.
Okay, and this should be pretty free flowing, and customers can upload anything. This should be fully automated. So I think we're going to need some kind of virtualization for this, because we don't want customers to accidentally upload something that breaks other things. So I'm going to create a section called non-functional requirements. So for this, because assuming, you just want to be able to upload anything, that's pretty clear. And there might be some limitations on that, but definitely, isolation and security. Should there be a length of time? Like maybe one of the things we might want to build is customers can pay more to run code that runs longer.
Mm-hmm. Yeah, so let's I love that idea. Let's start off really simple and just say that the maximum execution time for a job is 24 hours. And if we have time at the end, we can design more of these bells and whistles.
Okay. And the size of the customer base now matters a lot. If a job can run 24 hours, it's a lot of resources. Could we say maybe 10,000 customers at most?
Yeah, I want us to have 100,000 customers.
Okay. 100,000 customers. Okay. And each customer can run one job. Is that reasonable?
Yeah, so let me give you some kind of stats of our system. So We have 100 million jobs uh, per customer, and about 10 jobs per second per customer ran in the system.
Mm-hmm. Okay, cool. So it's 1 million jobs, 10 jobs per, 1 million jobs per customer. And this is just the number of possible jobs.
Right.
And 10 jobs per second ran per customer. Okay. This is a lot of,
And
lot of
yeah,
code.
and the other stat would be that we run 100 billion jobs a day. So we have a
Okay.
pretty beefy system here.
Okay. There's definitely, knowing that, I think this is going to, controlling cost of hardware might be one of the things we could definitely take a look at. And assuming none of these jobs are, we don't provide any extra storage for the system, just code and network calls per job. Is
Hmm.
that right? No, yes.
Let's say that they have like access to a very ephemeral storage disk, just enough to kind of like write out a CSV file or something like that, but just a very nominal amount.
Okay, so at least it's just code.
Hmm.
Um, okay, I think yeah, that's pretty good. Oh, and then public facing. I'm assuming we're gonna want a monitoring solution. So you submit a job, and then you see how it is and get some kind of note. There's no notification system. Just I don't know what do you want for the uh, public facing? Like, do you want notifications or a GUI?
Yeah,
Something.
let's not spend, I love both those ideas. Let's not spend too much time on the UI. Let's say that maybe we design a very simple API layer and we can talk about what APIs we need. Um, but the UI is just a wrap around that, and maybe it's like a console or whatever, right? Maybe we have a CLI or an SDK that call into our API. And um, in terms of APIs, we can figure out what we want to support for eventing. And I think in particular notifications, we don't have to support that off the start. We can just
Mhm.
give people kind of like a status API or something like that, maybe for their jobs. That way they could
Mhm.
know whether they're, successful or failed or whatever else. So they
Okay.
could call into that.
Okay. Okay. So we'll provide some kind of API. All right. Something, but we'll focus on it in a bit. Um, and the last question is there any memory limitation per job? Is it, because is there any sort of, and can jobs run slower if possible? Like if we have too many jobs on the server, can we tell customers that all the jobs are just going to run a little slower?
Yeah. So I think there's two questions there. One question is kind of what is our SLA around
Mhm.
how quickly a job should be executing by, right?
Yeah.
And then one question is, so sorry, before we handle the second one, let's take the first question. So this is another, we have an interesting SLA for that. I want it to be ideally at most a couple seconds to the point a job gets scheduled, right? And I'll
Okay.
give us the stretch goal of ideally it being less than 100 milliseconds from the moment someone kind of creates a job or tells it to execute to the
Mhm.
point it actually executing. Or similarly, like you can think of that as like Tuesday at 2 p.m. comes around, 100 milliseconds after 2 p.m. comes around, I would like that job to be running, ideally, like in the scheduled
Okay.
scenario.
Mhm.
The second question was around the memory profile of an individual job. Let's just say that, at most it's like 1 GB or something like that to start. I think that one could be similar to what you brought up at the start, where we could allow people to pay more and increase it or something maybe. But let's just start really simple and say that there's a 1 GB or something of memory is the limit. And if you go past that, then we and you crash.
Okay. Okay. Got it. Got it. Um, so I'm going to start off by saying this will be very expensive. Uh,
Yes.
and I don't see a way around that, but I do think that I can design something that, scales. And so and allows people to upload as many jobs as they need and scales. But I may not be able to support the service level agreement. It's going to be really, really expensive if we actually have 100,000 customers at first.
Yeah, let's talk about that in the pros and cons later on a little bit once we have more of the high level design. We can talk about the trade-offs between money and speed.
Okay, cool. So then I guess my first question is I'm already at the 15-minute mark, so I probably have over time, but I do feel like there was a lot to clarify with 100 billion jobs. I'm not sure if am I doing okay so far?
No, you're doing great. You're doing great so far. And take what I wrote there as a grain of salt. Those numbers are going to fluctuate a little bit depending on the question you get. This one has a lot of open-ended questions, right? Because you got to define, what does it even mean to upload a job? How many jobs are there? What is, the profile of these things, right? So you're asking all wonderful questions. Don't worry about being super strict. Yeah.
Okay. So then
the main point is eventually we should put a cutoff time, right? So probably in about 5 minutes or so, right? We got to put a cutoff and start getting to the design.
Okay. Well, I think I want to sketch out just what. I'm going to take a stab in the dark, and I have no idea what I should say next. But my imagination tells me that if I just throw out some kind of system here with a couple key parts, that maybe we can start to architect something. I'm going to try this. So I know we're going to need a load balancer because we have a lot of customers all uploading jobs at the same time. And we're going to need we're going to need a worker farm that runs all these jobs. We're going to need a database to track those jobs. And this database is going to have a lot of customers on it, 100 billion jobs a day. That's if each job is a single row in a database, it's 100 billion rows a day. So we have to think about sharding, partitioning, or sharding, and maybe even range-based queries based on day. Yeah, just like that. So, load balancer and a worker farm, and also an API layer between the load balancer and the worker farm. So far I've got these 4 components. So job comes in, goes direct to the load balancer, goes to, say, a stateless API layer. A new job comes in, goes to the database. And then something needs to tell the worker farm to pick that up. So let's say I don't know, some kind of message queue, like a message broker, or so some kind of like communications layer between the API layer and the worker farm, and whether that's a message broker or a poll-based system, I'm going to write that in comms layer. And that's kind of our sort of 4-piece overview so far. Wait, or 5-piece. 1, 2, 3, 4, 5.
Mm-hmm. Do you think we should switch over to the whiteboard at this point? It may be easier, I'm wondering, to kind of shift around the boxes and stuff.
Oh, yeah. Yeah, let's do that. So let's just do, so this will be load balancer. You just need a load balancer if you do this stuff. Stateless API gateway. Let's see. Yeah, and since everything is I'm going to assume everything is API based for now, and and clients will be notified in some way, but oh wow, this is really nice. Stateless API gateway, comms interface, like message queue or whatever it might be. And then let's see, worker farm. This actually runs the jobs. This is going to have some kind of virtualization. And then, yeah, a database to track jobs. Cool. I'm going to put
Yep.
the database to track, oh, whoa, put the database.
Maybe we could put that in the center of the picture because I think the gateway and everything will kind of touch this database in this diagram so far, right?
Yeah, so the API gateway gets a new job from the load balancer. And I'm just going into a little bit of detail right now to just try and define what is going to happen here in the general flow so we can flesh it out. Because I just want to nail down these boxes before I start to go in all these details and just make sure I've got the right boxes here. Like the gateway gets a new job from the load balancer and then goes from the database to track jobs, whether it's a new job or checking up on a job, whatever. The customer can go and access the database this way. If it's a new job, we put it into the message queue or have the worker farm pull the database or whatever it might be, but there's some way of communicating. And the worker farm does the job, and then as it's completed the job, it goes back to the database and tells the database, hey, I finished it. And then there's still a comms interface between the API gateway and the worker farm, so maybe the worker farm can go tell the gateway, hey, we're done, and then tell the client. So it's pretty basic so far. And there's a way to scale this, the database, because sharding and partitioning, maybe we even choose a different kind of database. You can scale the API gateway, the load balancer, and the worker farm can be scaled too. And same with the communications interface, we can change how we want to do that. Does that make sense so far?
Yeah, this all sounds pretty reasonable. I think we are missing a potential component here. Maybe we could walk through the two different scenarios that we have. So one is to schedule a job, right, at say like Tuesday at 3 p.m. And the other one is to run it as a one-off. So I could imagine the run as a one-off kind of being like execute job or something, right? And then maybe that API hits our load balancer and then it inserts into the queue and then gets picked up by a worker or something.
Right.
How about our scheduler path? So, that one I could picture maybe as like create schedule, we hit our API gateway, but then the rest isn't quite clear to me.
Right. We need some kind of scheduler. So in Linux, cron is just a process that sleeps until the next thing. It's kind of almost like a while loop, but not quite. But I'm thinking I just need some kind of long running service that just call the scheduler a scheduler, and the scheduler just repeatedly checks this database of jobs that need to be ran, and the database is also tracking a scheduled jobs too. So this database, yeah, I'm going to clarify this: jobs in progress, jobs scheduled, or just progress and scheduled. Okay. So yeah, the scheduler is a loop almost that just repeatedly checks to see if certain jobs are scheduled. And there may be some issues with that considering how many jobs we have. But ultimately it's going to be something that's pulling jobs that are scheduled from this database and telling the worker farm through this communications interface to run a job.
Okay, yeah, let's really quickly walk through the life cycle here. So this is kind of like create. One of the boxes disappeared. Oh, you moved it up. Okay, cool. So yeah, we have kind of like create schedule, and then maybe that inserts like a schedule record. Is that how you're thinking about this?
Yeah, it would insert. Yeah, there's two types of records in the database. There's a schedule record and jobs that are in progress already. And then the jobs that are in progress, we track their state in that table. So two main tables. There's also maybe a customer table too, but for now, this is what are we really, I just want to focus on tracking that.
Cool. So yeah, let's spend a little bit of time to design this in more detail. So
Okay.
I could picture this as kind of like create schedule, then we insert a schedule record, like you said, and then I guess the scheduler is polling the database to get. This is kind of like get schedules. Is that how you're
Yes.
thinking about this? Okay.
Yeah,
And
but there's an
then,
issue with that though.
yeah,
It's because if you have 100 billion jobs a day, and who knows how many of them are scheduled, there's no restrictions on that. It could be an issue. I'm thinking that maybe even instead of a scheduler, we might need something kind of like almost like a news feed generator for the worker farm. So there's something that's continuously generating what new jobs need to be ran, and then something else just picks that up repeatedly and sends that to the worker farm.
right.
Like it's actually
Yeah,
a two-part process.
yeah, exactly. So I want to talk about both of those. Yeah, definitely there's a scalability issue. Maybe we could say that, I guess looking back to our requirements here,
Hmm.
maybe we have like 10 million schedules or something like that. Um, sounds kind of reasonable for 100 billion jobs a day. Maybe like 10 million schedules.
Okay.
Um, but yeah, it's a lot of schedules, and we have this goal of 100 milliseconds. And yeah,
Hmm.
like how should we design our scheduler to keep up with that?
Yeah. So, um, I think to do that, I would really like to touch on what that database is going to look like, because there are so many jobs that if I just design the schedule without knowing what the data looks like, I could easily design the wrong thing. So I just want to create a table called scheduled jobs, um, and define what this means. So first, we might have a repeating job, right? And that might be a cron tab of I don't know the design of the scheduled jobs, and I didn't define this in the first part, um, but I think we could nail this down now. Um, so let's say we have one type of job, a repeating job, and another type of job called a just one-off feature job. Um, and there's two kinds, right? If that makes sense so far. I
Yeah.
don't think there's any more types of jobs, and a repeating job might just be once every minute, 5 minutes, month, whatever. It's cyclical, and one-off feature job is just once in the future. Um, does that sound good to you? I feel like this would reasonably serve our customer base.
Yeah, no, I agree. And I don't even know if I would call it like one-off future job. It's like I was picturing it as like do this thing now. Like it's like like
Oh,
immediate. I guess we could make it as like a future thing too. But either way, like maybe to simplify, we just think of that as like, hey, do this thing right now. Like we could think of it as like execute job.
okay. Execute job. Um,
Because if
so
it's in the future, like shouldn't they just like put a schedule? I mean, I don't
because
know.
I thought, well, I assumed repeating job is only one type of thing. It's every 5 minutes forever until you cancel
Hmm.
the scheduled job. But the one-off future job might just be instead of executing it now, you execute it 5 minutes from now.
Okay. Yeah, I like that idea. Let's focus, I guess, on the repeating job, and then the kind of immediate execution. I think if we just like the one-off future job is kind of like an enhancement of the repeating job. It's like
Yeah,
just a one-off version of that. But yeah.
cool. Um, so, uh, okay, so knowing that, we've got a list of jobs that are repeating forever until canceled. And so once a job is in the scheduled jobs table, it's going to just repeat forever. And then uh, I want to clarify that too, because the thing is, if I were to go and check every single repeating job, like say 10 million of them, it's going to take a long time. So I want to potentially partition this by kinds of repeating jobs. So I want to based on our scale and cost to reduce cost, I want to provide customers with a couple types of repeating jobs. So let's say 1 minute, 5 minutes, and daily. I know I could create all kinds of weird configurations of repeating jobs, but what do you think about this to reduce cost? Like, do you think I think our customers for many jobs would be able to do this just fine. 1 minute, 5 minute, and daily.
Hmm.
Okay.
I think going by the minute to start is okay. I would ideally like at the second level actually. Let's not worry about cost for now. Let's just worry
Okay.
about how to kind of scale the system.
Hmm.
So I think I want us to get back ultimately to our scheduler, right? So once we, like, how does the scheduler kind of work if we have a
Hmm.
1 minute frequency and all these schedules, like what'll the system do?
Yeah. So if we have a whole bunch of jobs that must execute every single minute, then we must go for every single scheduled job every minute and just take them all and put them into our queue to send to the worker farm. I call it
Right.
and that's what we were doing. And if we have 10 million of them, we're going to have to just create a sort of farm that, or split that database up and then just grab all of them en masse with several machines instead of just trying to do them all at once. I mean, we could, I could do some calculations to see how many machines, but I just want to leave that number open and just say we need to scale the number of scale the number of workers that are getting scheduled jobs. So
Yeah.
as I
Let,
was
let's let's probe on that thought. I love that thought that you had. Let's just jump to, like, we have to partition um,
Mhm.
a number of schedules somehow to some number of schedulers, right? Because if
Yeah,
I change the question to be at the second level, I know we'll end up in that position, right? And that's ultimately what I want us to support. Um, because to evaluate 100 million schedules in less than a second, we're going to have a problem, right?
right, right.
Pretty much no matter how much we optimize our database or how much hardware we throw at the problem. Um,
Yeah.
so if we were to kind of jump to that world where we know we need to partition things to some degree,
Hmm.
I guess, like, what would that look like? Like, what would our service kind of, how would it get partitioned? What would it look like? What would it do?
Yeah. So I'm gonna design a partition of scheduled jobs around, say, um, it's a good question because it could, in this case, I'm gonna take a stab in the dark and partition around, say, user ID, because user ID could be hashed, and then um, let's say many users will have jobs that all need to be ran at the same time, and so there'll be some sort of um, like continuity between the where the jobs are located. And I want to partition these jobs in a database such that every shard contains a subset of jobs per user. Uh, and then I want to, yeah, but then if we have 100 million jobs, and it's not 100 million new jobs every day, it's just 100 million jobs. So no, knowing that, like, is that correct? It's not an influx of 100 million new jobs. It's just
Right.
100
That's just
million
like the
jobs.
average running of the system. Yeah.
Awesome. Okay. We could partition that into, say, a couple, about a million rows per database, say have 100 shards. And then I think a SQL query could reasonably query a million rows in less than a minute and send those um, to the message queue to a worker farm. Uh, well, maybe. I mean, thing is to stream. Let's say a job is about a kilobyte. Streaming a kilobyte is what over a network, maybe, I don't know, a couple milliseconds or so. So if I have a million jobs times a couple milliseconds, uh, it might be about like 1,000. It could be like a couple hundred seconds to do all these little to stream that much data. It could be about a minute just to stream 1,000,000 rows at least, or two. I'm just doing some really sloppy math in my head, but I'm thinking streaming 1,000,000 rows from SQL might be an issue. But maybe not. The thing is, it's got to run every minute, so that those 1,000,000 rows have to come by fast. So how could we do this? Well, you know what? Maybe one of the bottlenecks is just the amount of data that we can, like 1,000,000 rows in a database is fine. I think 100 shards to hold 100 million jobs is fine. That's fine. It's like 100 little databases. That's cool. But the bottleneck could become, how quickly can I get 1,000,000 rows of data from each one of those shards into the worker queue? And so that's like an input-output issue. And I know each database might have multiple processors, let's say even 8 cores. Divide 1,000,000 rows by 8, that's about maybe 200,000 rows. I could totally stream 100,000 rows pretty quickly. I know that. So what I want to do is, for every single worker that's pulling jobs from this database, it spawns a couple threads that each pull data from the database, or a couple processes or whatever, and then each process is then sending data into the message queue. So it's like a combination of sharding and threading. Am I on a tangent, or I think that's
no, I think, yeah, I think this is the gist of one really complicated problem that I'm presenting for you. I like those ideas. I think we can totally get away with sharding. I think your ideas are good there. Maybe we can move past this one, and we'll circle back to this at the end, I think, of the interview. And I'll give you some more kind of different ideas on how you can think about that problem in the future as well, like some kind of out of the box crazy ideas. But I think what you presented makes total sense and will totally work as one solution here. One thing that I think will be fun to talk about next, actually, to kind of switch gears a bit, is to talk about this worker farm. And I wanted to talk about the directions of arrows, actually, here. So, like, one approach that in theory you could have is the scheduler kind of immediately pushes work to the worker farm. I kind of interpret this arrow as kind of like a pull model. I'm not sure if you pictured the queue kind of pushing into the worker farm or not, but I wanted to talk about the directions of these arrows, basically, and the pros and cons. And if we were to talk about these 3 different options here, what are the pros and cons of the 3 different designs here, perhaps?
So there's a couple ways of communicating with the worker farm. There's a message queue. Pub sub might be a little weird because only one worker needs to know about a job, not all of them. And there's a polling interface too. So I want to talk about message queue and polling. So if a worker farm repeatedly polls, let's say the database, going from here to here, that can cause a thundering herd issue if all the jobs are completed and suddenly overwhelm the database. But at the same time, polling is very easy to implement, and it's also useful to, if you just track, if we're creating some kind of scheduler, that tracks what jobs need to be ran, worker farms can just pull the top of whatever's in a scheduler and just execute that repeatedly. But then there's an issue because 2 workers might be polling for the same data and then getting the same jobs to be ran. And it's hard to coordinate 1,000 workers, for example, all polling the same database. So I would, in this case, prefer a message queue. just because it physically makes more sense, because you're just putting jobs into a queue to be ran, and the workers don't care how they're being ran. They just need to execute jobs as fast as possible. So I'd rather make this comms interface a message queue, and all the worker farm does is just pick up jobs from this queue. And so the workers are directly connected to the queue via socket, so there'd be no more number 3. Well, I mean, I guess if you think of, a socket, this is a listener socket, and this is a passive socket, and this is a active, listening to this one. It's just going this way, I guess, if I'm describing that right. It's just, the queue just sends to each worker what needs to be done. And then I can just eliminate a lot of complexity. But if I implement polling, suddenly I'm intermingling the logic of how things are scheduled with polling, and polling can be really easy to implement, but then there's a lot of caveats, like how do I make sure that 2 jobs aren't executed at the same time, or how do I lock rows to make sure they don't, update the same job. So I think a message queue is the best. And RabbitMQ would work.
So maybe we could say this is like RabbitMQ to start. So for this third option, I want to talk about it in a little bit more detail. So let's say that the queue maybe the queue has 1,000 records in it or something like that, right? Just kind of inserted pretty quickly, and the worker farm, like, how does it know which worker to assign things to, for example? Like, how does that interaction kind of look like? Like it kind of sends something to this worker farm, but presumably there's a ton of different boxes kind of in here. How does that look like? What does it do?
Yeah. So I'm imagining all of these workers connected to RabbitMQ at the same time. And I know this is sort of a bottleneck, but I know that RabbitMQ can store small amounts of stuff. I'm thinking that
So we're gonna have maybe, like, how many sockets are we talking about? We're gonna have maybe, I don't know, 10 million concurrent jobs or something, right? So 10 million sockets concurrently subscribed to the queue?
To RabbitMQ. Yeah, so Unix can have millions of WebSocket connections in a single server. It stores all the WebSocket connections in a single table, and you can see it in /proc/process_id/net. I think there's a separate file for it, and it's global to all processes. But then I think that's fine. But the issue is, what happens when RabbitMQ goes down and all those millions of connections have to come back up? That becomes an issue.
Yeah.
So knowing that, I'm thinking that maybe RabbitMQ might not be the best solution, because RabbitMQ it can be distributed, but it's more so for higher availability, and maybe a better solution would be something like Kafka, even though Kafka provides features we don't necessarily need, like, for example, publish subscribe and message ordering. Like, we don't care what order the messages are in. We just want them done as fast as possible. But Kafka does provide one thing, which is horizontal scalability and partitioning. So we can put these messages into separate partitions and put these worker farms into consumer groups, and then they can sort of just kind of offload. So, RabbitMQ, while it theoretically works and it has the right feature set, doesn't scale as well, because it's literally just a linked list. Linked list it's not a partitionable thing. So yeah, I want to do that and just have these into worker groups. And then each of these little workers is in a group. and then they're each subscribed to a partition in the job topic. We're going to create a job topic in Kafka, and they're all pulling from this topic. And that way, let's say some of these go down, that's fine. If Kafka can spin up more server instances, I believe that's how that works. Like there's producers and consumers. So on this side, we have producers. And if we have, that way, even though we could have millions of connections in one box, let's just not do that so we don't have the thundering herd problem if these all crash.
Mm-hmm. I want to say what you're describing is closer to number 2, by the way. And let me tell you why I think it's closer to number 2.
Okay.
It's because ultimately, say the specific box is trying to get work, right? This box needs to know that it can take the work on. So you're kind of saying that this box knows that it's ready to take work on, so that when I partition it based off of topic or whatever in Kafka, then it will know to kind of say, hey, give me more work, or like I'm ready to take more work, right? But if in number 3, I think what's not clear to me is like, say that something comes into a topic, right? Maybe there's 1,000 messages on a topic. If we just blindly push it to like one of these virtualization instances, like this EC2 instance or whatever it is, it may not even be able to execute the job, right? So then what happens? Does it re-enter the queue, or does it kind of fizzle out, or does it get queued in the EC2 instance waiting for the rest of the jobs to be presented? There's a bunch of issues essentially if you push directly on to the worker. But what I'm interpreting you say is closer to 2, I think, if I hear you right. Does that make sense? Those are the differences, I think, in my head between 2 and 3.
Yeah, so 2 is Kafka, 3 is polling, more or less. Maybe try this. Yeah, Kafka.
Well, I think 2 is kind of polling, like the workers are polling a topic, right? They're polling Kafka's topic. And the third one would be like if you had eventing from the topic, pushing somehow the work onto a worker farm. Yeah.
Yeah. Yeah, eventing from the topic to the worker farm. Yeah, there's issues with both of those. Yeah, what happens if a job gets stuck? So the consumer gets stuck, and then the consumer, I'm not sure, because I think we would need something to monitor the worker farm too. We would need something to track this database repeatedly and just query for the latest jobs that are stale, and then try them again. And we would probably need a health monitor for Kafka too.
Yeah, that makes sense. So we've got about 10 minutes left. I want to spend maybe about 2 or 3 minutes here just talking about the worker farm as well. And then we can maybe open it up kind of like a more free-form conversation. So for the worker farm, how are you thinking an individual box kind of looking like? There's a bunch of different problems. We didn't really, I guess, quite define how a job gets uploaded and ran in the system, right?
Yeah.
So, Deliberate Alligator uploads a job, and he's like, print hello world in Python. And then the worker farm somehow picks this thing up, and then it executes it. How does that work, I guess? What do I upload? What does the worker farm execute? How does it execute in any language, so on and so forth?
Yeah. So I thought that it's going to be a little bit simpler, but there's some API layer here. So I'm just going to define that from the API layer. So first, I want customers to create a job, and then I want them to say run a job if they want to, and then or schedule job, and that will have some other parameters like whether it's repeating, for example. And then so I hope I'm just answering the question the best way possible, but create job would You upload your code, and that code would be saved somewhere in this database. And it would create a job definition. And then running a job, you get like a job ID, and then you run the job. So that's a job ID. And you have to schedule job. You take a job ID and make it some parameters for repeating, and then you can say get all jobs. So this is what's between the load balancer and the API gateway. And then knowing that, like if you create a job, I hope I'm answering this the way you are looking for. But create job goes to API gateway and just saves into the database, and I can define that table. But that's just a table of jobs, with the code and the job definition.
Yeah. Well, I guess what are they really ultimately uploading, right? Like, is it a binary? Is it like a list of files that represent the program? Are we doing the compilation? Like, I think there's kind of some fundamental questions there.
Yes. So, I really want people to upload. I think the complexity of having people upload code directly could get really weird, because then we have to provide code environments for all different things people want to run. I would prefer.
Right, we have to compile everything for every language, like ever, with a bunch of flags and everything, right? That seems crazy.
Yeah, then we'd have to create a compilation design, and I don't want to do that. I'd rather create a Docker hub of some kind, or even just tell people to run jobs, just upload a Docker image. And then we could say, based on the 1 gigabyte memory limit, the image must be, say, less than a gig. So you give us a Docker image, and then the worker farm would pull that Docker image and run it. But then there's an issue of how long it takes to pull a Docker image in the worker farm. So that could, if a job has to run every minute and you got a ton of jobs to run and it takes 10 seconds to pull a Docker image, that's an issue too.
Is it an issue? Our requirement, I think, is just the start execution of the job, right? Like, it may not be the best customer experience to do a Docker pull. Tell me about that process and like the ramifications of that choice.
Yeah, so first we got to have some kind of hub to store all these Docker images, or we have to connect to Docker Hub. And if we have to connect to Docker Hub, we have to pay egress costs to AWS to pull a ton of images, and that could expand costs immensely. So I would prefer to create a Docker Hub ourselves, even though that might be complicated. So we might be storing Docker images in, say, S3, but at least, assuming this is all hosted in AWS, at least we're keeping everything within AWS. And creating a Docker Hub is also itself a thing too, but ultimately we're going to have these binary images. Maybe we can leverage some of the services in AWS, such as what is that thing called? Elastic Container Service. Or ECR, Elastic Container Registry. Sorry, ECR. That would help a lot,
right?
Because then
so when they create a job, they upload something to ECR.
Yeah. So you upload this to ECR, and this whole service could then maybe even be sold as a managed service for customers in AWS, and then expand later to other services like Google Cloud. But just make it managed AWS service, so users are posting their jobs to ECR, and then our worker farm pulls the image and runs it, and then deletes it after. There's a lot of pulling images. Like, what if we have 100 billion jobs a day and we're pulling 100 billion images, potentially even more often? I would love to have some kind of caching or something in the worker farm, so they don't have to keep pulling jobs as much. Like maybe some jobs could be tied directly to some worker farms, some workers, so that they just can do them repeatedly. Like maybe some workers could be doing just scheduled jobs and some workers could be just doing one-off jobs to reduce the amount of time we're pulling stuff from S3.
Yeah. Hey, so we've just got about 5 minutes or so left. I want to make sure that I spill over a little bit because I was a little bit late, and I apologize for that.
No, thank you.
Let's end here. I think you've done a wonderful job on this interview. I wanted to ask you how you thought it went.
I hope it went well. I mean, I just the first time I did this a year ago, like I totally bombed it. But I've been really studying and I've been doing a lot of work. So I just hope that I know I did better. I don't I don't know if
I've been asking this question, I think, for close to 3 years now. I think you're probably a top three person for me interviewing on
really.
this question. Not to toot your own horn too much, but I thought you did very, very well. So yeah, I think you're in a very good spot for your system design in general.
Oh,
I do have some things that you can improve on, but I think
yeah.
really what we would be discussing is the difference between like a senior engineer and a staff engineer. And the
Okay.
biggest gaps that I notice in you are kind of the next level architectural stuff is how I would describe that.
Mhm.
Can you still hear me? It's the
Yeah,
audio
yeah.
kind of went weird.
Oh no, I can. Yeah.
Yeah, so I think like the thing that I love about this problem is you can spend an enormous amount of time literally just talking about any box, right? And I think we can kind of dissect each box a little bit. But the main thing about the scheduler, for example, that I kind of pulled us away from is the fastest way to do pretty much any computation is to put everything in memory, right? And I feel that I kind of felt that you haven't really ever implemented a true distributed system sharding thing on your own, like that's not using some other kind of technology. That was kind of the impression that I had got out of this interview. So like I think the one of the big differences between that kind of senior and staff level system design will be when you're talking about a scheduler kind of component like this, you're going to be able to express like, oh, hey, maybe there's going to be like a leader election algorithm where we split the partitioning based off of this or something like that, right? Like I felt like our conversation was pretty high level, right? It was like shard based off of customer ID, but like who manages the shards? How does the shard happen? What algorithm does it use? What happens when a shard fails? Like all these different kind of availability concerns. And I think that's where like just more depth will take your interview to the next level, right?
Okay.
Like bring up like a zookeeper or something like that in a situation like that, and then you can kind of rattle off about, hey, there's a master slave relationship between these things and you can have partitions for your partitions and so on and so forth, right?
Yeah.
The only like kind of real fundamental thing that I think you missed in your requirements gathering is probably the size of things as well. So the real challenge in this system is just the scale. And because we have so many different objects, one aspect that we never really got into is how do you make the database scale? Like if you have 100 billion jobs a day, like eventually you're just going to run out of memory. Like if you were to put a back of the envelope napkin math thing of like, I don't know what a job is, maybe 1 or 2 KB, right? Like the amount of memory you're going to use is crazy. And what does it look like to kind of, roll over the partitions and is even realistic to fit it in memory, right? So the strategy that in the blog link that I linked at the start of the interview has a section dedicated to kind of doing that basic math. I think that's another piece that you could kind of add to your repertoire. But yeah, like you called out a ton of pieces that a lot of people just don't even think about, which I really love. It shows that you're really customer obsessed and thinking about things from your own perspective, right? And that gives me incredibly high confidence that you'll be successful on pretty much any team that you would join. Like a lot of people don't even know the history of Docker Hub and how Docker works or pulls, or like they'll even struggle to come up with their own virtualization concepts. So you have like a lot of breadth, which is fantastic. The only caveat I tell you is in interviews, like, and maybe you notice myself doing this, is pulling yourself back, right? So don't feel like you have to design every bell and whistle, right? So bring them up and say, hey, should I focus on this thing? It's really easy to lose all your time without focusing on the core components. So for you, I think I always had to pull you back a little bit, right? And like, hey, I want you to focus on this thing rather than that like really cool idea you had. So try to work with your interviewer essentially to focus on the meat of the problem so you make sure you get it answered, because I'm very confident you can get it answered, but you may distract yourself basically with all the great ideas you have on the side. And that's just a time management thing. But anyways, I thought you did a fantastic job. Thanks for spending time with me. Did you have any questions, or does that all kind of make sense?
That does make sense. So I feel like if I just really go into depth on distributed systems management, because I understand sharding and I understand NoSQL and how to query them, but I really didn't go into how to manage it. And I wish I had thought of the scheduler memory, because you're totally right. Like if you just create something in memory in a scheduler, that's really fast to schedule all these jobs in memory. And then there's ways of making that durable too. But I think what I could do is just today, just create an outline of all the concepts I need to manage, like a NoSQL database and a Postgres database, and then with Zookeeper and sharding and partitioning and what happens if shards goes down and leader election. Like I've learned all these concepts before, but I just have not put those particular concepts together yet, I think.
Yep. The last thought I'll leave you with, and I apologize, I really got to go. I'm back to back here.
No problem.
Is we didn't talk about like scaling the worker farm and keeping it up to date. So because you know all the schedules and things in advance, you know exactly how many workers to partition at a point in time. It's not immediate to spin up like a virtualization instance or hardware. So there's other pieces of this design that you can kind of extend. I have no doubt that you would think of it. But the main point I think is like ask your interviewer like, hey, what should I spend my time on? Should I work on this thing, that thing? Right? It's a very bi-directional conversation. So don't feel bad about any of those things like I mentioned. It's just, things to kind of elevate your responses, right? I think you're in a fantastic spot. Yeah. So thanks for spending your time today with me.
Last question.
It was a pleasure.
Thank you. Would it be as a senior engineer, hire or no hire? Just curious.
Oh, absolute hire. Yeah, absolute hire for me, without a question. Yeah, I think you're borderlining the staff range. So don't undersell yourself. I would love to hire you for my own team. So, I'll give you more of a write-up.
Wow, cool. Okay. Yes.
Cool. I really have to run. I apologize, but I'll send you some more notes and things that I hope are helpful. Okay, and have a great week. Take care.
Thank you. Bye.